Think about this for a second. You build a spacecraft, you spend 10 years on it. You spend more money than your country can really afford. You launch it on a rocket the size of a building, send it 261 million kilometers across the solar system, slow it down, drop it through an atmosphere that's trying to crush it, land it on the surface of another planet, and then gently, perfectly, you swing out a robotic arm to test how hard the ground is. The arm works, the data comes back, clean and beautiful. The surface is incredibly hard, completely rigid, zero compressibility, and then the camera scans the area, and you see, in the image, that your beautiful robotic arm is not pressing on the ground at all. It's pressing on a piece of your own spacecraft that fell off 30 seconds earlier and landed in exactly the wrong spot. The actual surface of another planet is 3 centimeters away, untouched, unmeasured, just sitting there in the frame, perfectly visible, perfectly out of reach. That spacecraft was called Venera 14. The year was 1982. And that mission is not the embarrassing footnote of the Soviet Venus program. It's the perfect summary of it. But that's not even the strangest part of this story. The strangest part is that this happened 43 years ago, and the photograph that Venera 14 sent back is still one of the only ground-level images of Venus that exists anywhere on Earth. The country that built it doesn't exist anymore, the engineers are mostly dead, and nobody has been back. And there's one more thing. A senior Soviet scientist re-examined those photographs in 2012 and saw something the global scientific community very quickly tried to make go away. If you want stories about the corners of the solar system that nobody else is telling properly, like and subscribe. Astrion covers the things space agencies don't want repeated. Now let me actually take you back to the beginning. Picture this. It's 1967. The Cold War is at full temperature. 2 superpowers are racing each other to plant flags on every world they can reach. The Americans have just decided Venus is too hard, and they're focusing on the moon. The Soviets have decided the opposite. They're going to land on Venus first. There's just one problem, and the problem is nobody knows what Venus is. I mean it. Almost everything we thought we knew about that planet in 1967 was wrong. Astronomers in both countries genuinely believed Venus was a warm, tropical world. A humid swamp, surface temperature maybe 60 degrees Celsius. Soviet engineers literally built sensors calibrated to detect water on the Venusian surface because the prevailing scientific model said Venus probably had oceans. You heard that right, oceans on Venus. The planet that today we know is hot enough to melt lead. So with that picture in their heads, the Soviets built a small aluminium capsule called Venera 4. They engineered it for an atmospheric pressure of 20 atmospheres. That was the consensus estimate. 20 was the number everyone agreed on. It launched in June 1967. 4 months later, it arrived. It deployed its parachute. It began its descent into the atmosphere. At 27 kilometers above the surface, the signal went dead. Now stop and think about what that means. Venera 4 didn't crash. It didn't burn up. It was still 27 kilometers in the sky when it stopped transmitting. That altitude is above commercial aircraft cruising height on Earth. It was nowhere near the ground. So what happened? Venera 4 was crushed, physically imploded. The atmospheric pressure at that altitude at 27 kilometers up was already past what the hull was designed to handle. The team in mission controls sat there watching the telemetry flatline and slowly began to understand the scale of how wrong they'd been. The actual pressure at the surface of Venus is not 20 atmospheres, it is 90, the equivalent of standing 1 kilometer underwater on Earth. The Soviet team had built a spacecraft to handle a bath. Venus was the ocean floor. This is where the story really starts, because what happens next is one of the most insane engineering campaigns in the history of spaceflight, and almost nobody in the West has ever heard the details. The next launch window was less than 2 years away. The team couldn't rebuild from scratch, so they tried a trick. For Venera 5 and Venera 6, they made the parachute smaller. The logic was simple, and you can almost feel them grasping at it. If the probe falls faster, it spends less time exposed to the crushing pressure. Maybe it can reach the ground before the planet destroys it. Both probes imploded 11 kilometers above the surface. So they went back to the drawing board, and what they came up with for Venera 7 was something nobody had ever built before. They abandoned the idea of a spacecraft entirely. They built a deep-sea submarine. I want you to picture it, a forged titanium sphere, rated for 180 atmospheres, double what Venus would actually throw at it, with margin for error. They stripped out almost every scientific instrument to save weight for armor. They removed the windows. They replaced the solar panels with batteries. The result was, basically, a metal ball with an antenna, a diving bell designed to survive hell. It launched in August 1970. When it arrived at Venus, the parachute deployed exactly as planned. And then the reefing cords melted, because nobody on Earth had ever designed a parachute that could survive Venusian atmospheric temperatures. Venera 7 fell. It hit the surface at 17 meters per second. The telemetry stream flatlined the instant it touched down. The mission was marked as another total failure. Everyone went home. Now here's where it gets interesting. 3 weeks later, an astronomer named Oleg Zhiga is sitting in a quiet room with magnetic tape recordings of the raw radio signal from Venera 7. He's not even really looking for anything specific. He's just running noise filters across the static, the kind of work you do when there's no expectation of finding anything. And then he sees it, a pattern, in what everyone had assumed was meaningless noise. Zhiga keeps processing. He turns the gain up, he filters more aggressively, and slowly, faintly, at 1,000th the strength of the probe's intended signal, he starts pulling data out of the noise. Venera 7 had not died. It had toppled onto its side when it landed, pointed its antenna away from Earth, and was still whispering. For 23 minutes after the supposed flatline, it had been transmitting temperature readings from the surface of Venus, broadcasting weakly in the wrong direction with nobody listening. When Zhiga finally pulled out the actual numbers, he had the first information any human machine had ever transmitted from the surface of another planet. It said the temperature was 475 degrees Celsius. That's hot enough to melt lead, hot enough to melt zinc, hot enough to destroy every electronic component humanity had ever built within seconds of exposure. The pressure problem had been solved. Now the temperature problem was about to redefine everything. Now think about what 475 degrees actually means as an engineering problem. On Earth, when you have hot equipment, you cool it, you use radiators, you use fans, you use refrigeration cycles. All of those things work because there is somewhere colder to put the heat, the surrounding air, the water in a coolant line, the cold side of a heat pump. On Venus, the air outside your spacecraft is hundreds of degrees hotter than the machinery inside it. Every cooling system humans have ever designed assumes there's a cold sink somewhere. Venus does not have one. So how do you keep a spacecraft alive in an environment where you literally cannot remove heat from it? The Soviet engineers came up with something I'm going to call the block of ice doctrine. They couldn't cool the probe in flight, so they pre-cooled it. Before the lander separated from the orbiter still in the relative cold of space, before it ever touched Venus's atmosphere, they pumped supercooled fluid through the pressure vessel and brought the internal temperature of the probe down to -10 degrees Celsius. The probe began its mission as a block of ice falling into a furnace. That gave them a thermal head start, but it wasn't enough. So they packed the inside of the lander with lithium nitrate trihydrate, a chemical with a melting point of exactly 30 degrees. As heat from the Venusian atmosphere penetrated the titanium hull, that heat went into melting the lithium nitrate, a process that absorbs enormous amounts of energy without raising the surrounding temperature. The lithium nitrate was a thermal buffer, a kind of internal ice cube designed to keep the electronics alive by sacrificing itself. It bought them 50 to 60 minutes. Every Venera lander, from this point on, was on a clock the moment it hit the ground. The clock started at -10 degrees internal. It ended when the lithium nitrate boiled. Now let me ask you something. How would you take a photograph in those conditions? Because a regular 1970s television camera uses a cathode ray tube and a glass lens. And glass under 90 atmospheres of pressure is a bomb waiting to detonate. You cannot put a window that large into the side of a pressure vessel without inviting an immediate, catastrophic implosion the moment the lander touches down. So the Soviet engineers didn't use a camera. They used something called a telephotometer, and the way it worked is genuinely beautiful. Imagine you're inside the cooled titanium sphere. There's no window, just a tiny cylindrical quartz porthole smaller than a coin, thick enough to survive the pressure. Behind that porthole is a small mirror. The mirror rotates incrementally, first measuring the brightness at one point of the surface, then turning slightly to measure the next point, and the next, and the next. It builds a panoramic image one dot at a time, like a fax machine scanning a photograph through a keyhole. It is unbelievably slow. A complete panorama takes 30 minutes to construct. The probe doesn't send back an image. It sends back a long stream of numbers, a column of telemetry that computers back on Earth have to reassemble line by line, dot by dot, until a picture appears. That's what every photograph of the surface of Venus you have ever seen looks like before it becomes an image. A column of numbers, a signal from a spacecraft built like a submarine, packed with melting ice, looking at hell through a keyhole, slowly painting a picture before the heat killed it. On October 22, 1975, Venera 9 survived everything. The titanium sphere held, the lithium nitrate held, the telephotometer's mirror started rotating. The first dots came through, the first lines, and then slowly, an image began to appear on the screens in Moscow. You have to understand what was happening in that room. Every prediction about what they would see was wrong. The scientists thought the surface would be dark pitch black or barely lit. Venus's atmosphere is so thick, the assumption was that almost no sunlight could penetrate to the ground. They had installed floodlights on the lander to illuminate the surface for the camera. The floodlights were never needed. When the first image came through, the surface of Venus was bathed in soft, diffuse orange light. The kind of light you'd get on a cloudy summer day in Moscow. Bright enough to see by, bright enough that the floodlights had been a complete waste of weight. Reality had just politely informed the Soviet team that another assumption was wrong. And the rocks, everyone expected smooth, wind-worn pebbles. Venus has 90 atmospheres of pressure. Surely the wind down there would have ground everything to dust over billions of years. The image showed the opposite, sharp, angular black rocks scattered across a flat plain, fresh edges, recent geology. The wind speed at the surface turned out to be barely half a meter per second. Almost still air, a planet that looked in the image like it had been broken open and frozen. 3 days later, Venera 10 landed 2,000 kilometers away. It sent back a completely different scene, flat slabs of basaltic rock, smoother terrain, older landscape. 2 probes, 2 views, the same planet, telling us for the first time that Venus has geography. Mountains, plains, slopes, distinct regions. But these images were black and white. They showed shapes. They did not show color. They did not show what a human being would actually see if they could stand on the surface of Venus. That came in 1982, and what came back broke something in how we think about that world. Here's where I want you to slow down with me for a second. I'm going to describe to you what the surface of Venus actually looks like, what your eye would see if you could stand there for the few seconds before you died. Because almost nobody describes this correctly, and once you understand it, you can't unsee it. Venera 13 landed on March 1st, 1982. It survived 127 minutes, more than double its design life, the longest any human machine has ever operated on the surface of Venus. It carried a redesigned color telephotometer that captured images through red, green, and blue filters, which Earthside computers reassembled into composite color photographs. The images that came back showed a world that is orange. Not orange tinted, not orange in places, entirely suffocatingly monochromatically orange. The rocks are orange, the sky is orange, the horizon is orange. There is no other color in the frame anywhere. Now think about what that means. Your eye on Earth sees color because the white light of the sun contains all wavelengths, every color mixed together. Your brain uses that white reference to identify what red is, what blue is, what green is. You can compare, you can correct, you can see the world in color because you're working with a complete spectrum. The atmosphere of Venus is 90 kilometers thick and packed with sulfuric acid clouds. It is so dense, so thick, so chemically aggressive that it acts as a 90-kilometer filter on sunlight. Blue wavelengths are absorbed before they can reach the surface. Green wavelengths are absorbed. Yellow wavelengths are partially absorbed. Only red and orange make it through to the ground. So if you stood on Venus, you would not see Earth colors with an orange tint, the way you might think. You would see a world that contains no other color at all. Your eye would have nothing to compare against. There would be no white in your field of view, anywhere, to use as a color reference. Your brain would be unable to perform the corrections it normally does. Everything would look like it was painted with a single hue, hot rust, glowing skin, ember light. And you'd know with certainty that you were not on Earth, because no human eye has ever experienced a sky that contains only one color. The Venera 13 calibration target, a strip of pure white paint mounted on the spacecraft, appears in the transmitted image as orange. The blue strip appears as black. That's what the surface of Venus actually is, not a hot planet with weird colors, a monochromatic world, suffocating single-hued, hot enough to melt lead. This is the first true color image of an alien world, and we have 9 of them. Then came its twin, and the twin gave us the photograph everyone laughs about. Venera 14 launched 5 days after Venera 13. It landed on March 5, 1982, about 1,000 kilometers from its sister probe, in a flatter region. Terrain that looked like cracked pavement, basaltic slabs, older landscape. The mission was identical. Photograph the surface, sample the soil, analyze the atmosphere, and then run one specific test that Venera 14 had, which Venera 13 didn't. It carried a spring-loaded compressibility arm, a simple instrument designed to swing out from the base of the lander and strike the ground with a known calibrated force. By measuring how far the arm penetrated, scientists could determine whether the surface beneath the probe was loose dust, packed regolith, or solid rock. The arm fired. The telemetry came back to Earth. The data was textbook clean. The surface of Venus, said Venera 14, is incredibly hard, completely rigid, zero compressibility. A perfect measurement. Now I want you to picture the scene in Mission Control in Moscow when the camera image came back a few minutes later. Because it's only when the panorama started to assemble dot by dot, line by line, on the screens at Mission Control that the engineers realized what they were actually looking at. The compressibility arm was clearly visible in the image. The arm had deployed, the arm had struck, the data was real. There was just one problem. The arm was not pressing on the ground. It was pressing on a small, half-circle piece of titanium, which the engineers watching the image render immediately recognized. Because they had designed it themselves, it was a lens cap. Here's what had happened. Both Venera 13 and Venera 14 had cameras protected during descent by titanium covers to shield the optics from the heat and pressure of the descent. Once on the surface, pyrotechnic charges firebang and the covers blow off, clearing the view for the scan. On Venera 13, the lens caps had popped off and rolled away. On Venera 14, one of them did not. It ejected, traveled a short distance, and landed perfectly underneath the spot where the compressibility arm was about to deploy. 30 seconds later, the arm swung down and hammered the lens cap with calibrated force. The probe dutifully measured the hardness of its own titanium. The actual Venusian surface was 3 centimeters away, sitting in the frame perfectly visible, untouched and unmeasured. You can look at the image right here. It's not a joke or a recreation, it's the actual Venera 14 panorama, with the compressibility arm clearly pinned down on a half circle of metal that the probe brought from Earth, with a real Venus just out of reach in the same frame. Now sit with that for a second. The Soviet engineers had built a spacecraft to survive the atmospheric pressure of being 1 kilometer underwater. They had designed a thermal system that brought it 60 minutes in a 475-degree furnace. They had navigated it 261 million kilometers across the solar system. They had landed it gently in a region nobody on Earth had ever seen before. And then they watched it pin down a piece of itself and measure its own discarded equipment. That photograph is the entire Soviet Venus program in a single image. Decades of engineering brilliance, defeated by a piece of safety hardware that didn't roll quite far enough. It is, no exaggeration, the most absurd mechanical failure in the history of planetary exploration. And it's funny, actually genuinely funny, until you remember one thing, that the lens cap was the successful mission. Here's where this story stops being funny. Stop and think about what I just told you. Venera 14 survived. It captured panoramic images. It analyzed the soil through other instruments. It returned more scientific data than any prior Venus lander. The compressibility test was one of many experiments, and even then, the failure wasn't a flaw in the design. It was 30 centimeters of bad luck. If this is the most absurd failure in the program, the successful missions were ones where engineers had built submarines to land in fire, lost most of their probes to crushing pressure, and got lucky with the ones that survived. We do not have backup photographs of Venus. We do not have second tries. Every single ground-level image of Venus that exists today was taken by one of 9 probes. Venera 9, 10, 13, and 14 between 1975 and 1982. That is the entire visual record of the surface of our nearest planetary neighbor. 9 pictures over 7 years, 43 years ago. And there's something else. In 2012, 30 years after Venera 14 melted on the surface of Venus, a senior Soviet planetary scientist named Leonid Ksanfomality published a paper in the journal Solar System Research. Now I want you to understand who this man was. He was not a UFO blogger. He was not some fringe theorist. He had personally designed instruments that flew on Venera 9 through Venera 14. He was the man who proved Venus had lightning storms. He had spent his entire career on this planet. In every meaningful sense, he was one of the architects of the Soviet Venera program. For 30 years, the Venera 13 panoramas had been treated as exactly what they were sold, as pictures of dirt, rocks, and the base of the lander. Geological data on a dead world. Leonid Ksanfomality re-examined them. He had something Western scientists had never seen. Not the cleaned-up final images that had been distributed to the public in the 1980s. He had the full panoramic sequences, multiple exposures of the same patch of ground, taken at different timestamps over the 127-minute mission. He aligned them, he compared them frame by frame, and he found things that should not have been there. Objects between 10 and 50 centimeters across, objects with what he described as unusual morphology, objects that appeared in some frames and were absent from others, objects that by his analysis appeared to slowly move or change shape between exposures. He named them a disc, a black flap, a scorpion, a stem, and a flower. The scorpion was the most controversial. A segment elongated shape in one of the Venera 13 panoramas, about 15 centimeters long, with a central body and what appeared to be a curved tail. In one frame, it was there. In a later sequence, it was gone, leaving what Ksanfomality described as a trace in the surface where it had been. His exact wording in the paper, translated carefully from the Russian, was this: "Let's boldly suggest that the morphological features of these objects would allow us to say that they are living." A senior Russian planetary scientist had just suggested, in a peer-reviewed journal, that a Soviet spacecraft photographed something alive on Venus. The response from the global scientific community was not curiosity, it was not even debate, it was a rapid, coordinated burial. Within days, Western media outlets ran the same explanation. The disc was a lens cap, the scorpion was image noise, a smudge enlarged beyond what the original data could support. The black flap was thermal insulation peeling off the lander as it cooked. The objects didn't move, they were 2 different lens caps photographed in 2 different positions, mistaken for one object that had walked across the frame. It is, on the surface, a reasonable explanation. Venera 13 did eject 2 lens caps. The probe was wrapped in insulation that melted and peeled off as the temperature rose. The image processing was crude. But here's the part nobody mentions. Ksanfomality knew about the lens caps. He helped design the experiments. He published his analysis in full knowledge of what spacecraft hardware was visible in the frames. He was not confused. He was not seeing what he wanted to see. And he spent the rest of his life until he died in 2019 defending his analysis. He expanded the catalog. He pointed to similar objects in panoramas from Venera 9 and Venera 14 as well, separated by hundreds of kilometers, taken 7 years apart. He published follow-up papers. He kept writing. If these were all lens caps, then the lens caps had multiplied. If these were all artifacts, then the artifacts had developed a habit of appearing in geologically appropriate places with biologically suggestive shapes across multiple missions at multiple landing sites. The Western scientific community called it pareidolia, the human tendency to see faces and creatures in random patterns. Ksanfomality called it the most important biological discovery in the history of planetary science. Both of them cannot be right, one of them is wrong, and nobody is going back to settle it. That, in the end, is the actual story. Not the lens cap, not the scorpion, not even whether something on Venus stood very still for a panoramic camera in 1982 and then quietly walked out of frame before the heat killed everyone watching. The story is the silence after, because here's where it gets uncomfortable. In 2020, an entirely separate research team announced the detection of phosphine gas in the upper atmosphere of Venus. Phosphine on Earth is produced almost exclusively by anaerobic life microbes living in oxygen-free environments. The detection was contested, then partially confirmed, then contested again. The debate is ongoing. In 2023, another team identified ammonia in the Venusian clouds, another molecule with no good non-biological explanation in that environment. Now nobody is saying these atmospheric findings prove Ksanfomality was right. They don't. The phosphine and ammonia in the clouds are completely different claims with completely different evidence at completely different altitudes from the alleged objects on the surface. They could be entirely unrelated. But the larger question, the one the scientific establishment was so eager to close in 2012, has refused to stay closed. Venus may not be sterile, some part of it, somewhere, may not be dead. And we have not been back to check. NASA's Da Vinci mission, currently scheduled for the early 2030s, will drop a probe through the Venusian atmosphere. But it's not designed to survive on the surface long enough to take more than a few seconds of imagery. The European Space Agency's Envision orbiter will map the surface from above, but will never touch it. The Russian Venera D mission, the proposed successor program that actually would return a lander to the surface, has been delayed for over a decade and currently has no firm launch date. The first time anyone seriously revisits Ksanfomality's question will not be this decade, probably not the next one either. We have sent rovers to Mars that stream high-definition video daily. We have flown a helicopter through the Martian atmosphere. We have flown past Pluto. We have flown through the atmosphere of the Sun. We have not, in 43 years, sent another camera to the surface of the second planet in the solar system. Remember the opening of this video? I told you about a spacecraft that accidentally measured itself. A lens cap, a robotic arm pressing on the wrong piece of metal, the most absurd failure in the history of space exploration. That story is funny. It's the kind of thing that gets reposted on the internet every couple of years, and people laugh at it. But now, I want you to look at that photograph again with what you know now. The lens cap is still there, the arm is still pressing on the wrong thing, the actual Venusian surface is still sitting just out of reach in the frame. But the lens cap is not the joke. The joke is that this happened 43 years ago on a planet we still know almost nothing about, where a Soviet scientist insisted to the end of his life that he had photographed something alive, and the world's response was to call him senile and to never go back. The lens cap is the punchline of a 1982 mission. The silence since is the punchline of everything that's happened in our entire generation of planetary science. That patch of dirt near Phoebe Regio is the most photographed, unphotographed thing in the solar system. The probe got close enough to see it, it did not get close enough to measure it, and 43 years later, neither has anyone else. You can find the Venera panoramas online, they are public. The Don Mitchell reprocessed versions are particularly good. He's a planetary scientist who spent years in the 2000s going back to the raw Soviet telemetry data and rebuilding the images with modern computers, revealing details that had been invisible for 30 years. Look at them. Look at the Venera 14 image with the compressibility arm on the lens cap. Look at the object's Ksanfomality, circled in red and labeled. Decide for yourself whether you're looking at hardware and noise and a tired old scientist seeing things, which is, honestly, the simplest explanation and is probably the right one, or whether something stood very still for a panoramic camera in 1982 and then quietly walked out of frame before the heat killed everyone watching. Maybe it really is just lens caps. But notice how badly the institutions wanted that to be the answer. Notice how quickly the question was closed. Notice that no one has gone back. And ask yourself why a planet we have not visited the surface of in over 40 years. A planet where a respected scientist insisted to the end of his life that he had photographed living organisms is treated as a closed case. The Soviets pointed a camera at Venus. The camera saw something. We still don't agree on what, and until somebody is willing to send another lander into that furnace and photograph the same patch of ground, we are not going to.